Welcome to the DIY Honda Garage channel. This presentation addresses diagnostic trouble code DTC P2074, which indicates that the manifold absolute pressure MAP sensor signal is lower than expected in the 2022 and newer Honda Civic models. The MAP sensor plays a crucial role in monitoring the intake manifold pressure, which is essential for the engine control module, also called the Powertrain Control Module, PCM, to calculate the air density for optimal engine performance. Located in the intake manifold, this sensor sends critical data to the PCM, which then adjusts fuel delivery and ignition timing based on the readings. When a discrepancy is detected between the MAP sensor output and other sensor data, particularly from the barometric baro sensor and the turbocharger boost sensor, the PCM logs DTC P2074, indicating an abnormal condition that needs immediate attention. The troubleshooting process for this DTC will involve a systematic approach to diagnose and rectify any issues with the MAP sensor and related components. The error description for DTC P2074 emphasizes the faulty communication between the MAP sensor and the PCM due to the presumed deviation of the MAP sensor output value from the expected values of the barometric sensor and turbocharger boost sensor. The MAP sensor is vital for measuring the pressure in the intake manifold, which helps the PCM determine the optimal air-fuel mixture for combustion. When the MAP sensor reports a value that suggests a problem, the PCM flags the issue and stores DTC P2074. This can happen during specific driving conditions, indicating a persistent problem that could affect engine performance, fuel efficiency, and emissions. Identifying the functioning of the MAP sensor in context with the other sensors is crucial for establishing the root cause of this DTC. The most common causes of DTC P2074 include a faulty MAP sensor itself, which may not accurately reflect the pressure readings due to wear or internal damage. Wiring issues, such as frayed wires, poor connections, or corrosion, can significantly impede the signal transmitted by the MAP sensor to the PCM, leading to incorrect readings. A malfunctioning PCM can also erroneously interpret sensor data, triggering the DTC despite having a functioning MAP sensor. Having knowledge of these possible causes allows technicians to focus their diagnostic efforts more efficiently, helping expedite the repair process. Each component needs to be examined and tested to confirm its functionality and ensure that the data sent to the PCM is within acceptable parameters. Several symptoms might emerge when the P2074 DTC is present. Drivers may first notice poor engine performance, as the incorrect MAP sensor signals can throw off the air-fuel mixture and timing adjustments, resulting in rough idling or hesitated acceleration. Consequently, there may be an increase in fuel consumption, indicating that the engine is not operating at optimal efficiency. The illuminated check engine light will serve as an alert to the driver that something is amiss. Importantly, the existence of DTC P2074 in the onboard diagnostics will help mechanics track down the issue. Being aware of these symptoms is vital for timely diagnosis and repair to avoid additional strain on the engine, thereby ensuring long-term vehicle health. The first troubleshooting step involves starting the engine and holding the engine speed at 3,000 revolutions per minute, RPM, without load. For vehicles equipped with a continuously variable transmission, CVT, this means placing the vehicle in either park or neutral, while manual transmission, MT vehicles, should be in neutral. Once the engine is running at the specified speed, it must be maintained until the radiator fan activates, indicating that the engine has reached a specific operating temperature. After this process, the vehicle should be allowed to idle for at least 5 seconds. This step is crucial, as it ensures that the vehicle is under conditions where the MAP sensor can provide its reading reliably without additional loads affecting the outcomes. The second troubleshooting step requires a test drive where the vehicle is driven under specific conditions. The vehicle should be driven with a speed range where the engine speed is maintained above 1700 RPM, ensuring that the sensor readings can be accurately monitored while the vehicle is in regular driving conditions. For vehicles with automatic transmissions, the gear should be in drive, while for manual transmissions, it should be in fourth or fifth gear. During this drive, it is essential to adapt the driving behavior so that the HDS, or Honda Diagnostics System, shows the relative throttle position, RELTP sensor, above 42.2 degrees. These parameters help ensure that the PCM has enough data to confirm the presence of the DTC after the test drive has been completed. The third troubleshooting step involves closely monitoring the HDS during the test drive to check for the presence of DTC P2074. Technicians should pay particular attention to the readings of the sensors, including the map sensor and the turbocharger boost sensor, ensuring they operate within expected ranges. If the HDS shows DTC P2074 during this check, it confirms that there is a recurring issue with the map sensor signal. It is vital to verify these readings at the same time to ascertain whether the discrepancy between the map sensor output and the expected values is significant enough to warrant further investigation. This monitoring step is crucial for isolating the problem and determining whether the map sensor or another component is at fault. In the fourth troubleshooting step, the vehicle is turned to the on mode without necessarily starting the engine, and the HDS system must be engaged. Here, technicians will confirm the data displayed for the map sensor at high resolution alongside the turbocharger boost pressure readings. The normal condition indicates that both the HDS map sensor and the HDS turbocharger boost pressure values must differ by less than 30.6 kilopascals, which equates to 9.0 inches of mercury or 230 millimeters of mercury. If readings exceed these parameters, it confirms a malfunction in the map sensor. Adequate verification in this step ensures a clear context for subsequent troubleshooting processes, ultimately leading to accurate repair actions. After addressing any faults identified in the previous troubleshooting steps, final repair verification is essential to ensure that the problem has been resolved. This involves confirming the successful installation and functionality of the map sensor. Technicians should also perform an inspection of the wiring integrity, looking for any continued signs of damage, wear, or poor connections. Once these checks are complete, it will be necessary to retest the vehicle for DTC P2074 using the HDS system to ensure that it no longer appears. This thorough verification serves not only to confirm the current repairs, but also to ensure overall vehicle reliability, preventing similar issues from recurring in the future. A successful resolution means both the sensor and related circuits are operating within the expected ranges. Preventive maintenance is key in avoiding the recurrence of DTC P2074 and ensuring longevity in engine performance. Regular checks of the map sensor and associated wiring integrity should be part of routine vehicle maintenance. Keeping tabs on engine performance can help uncover other potential issues before they escalate, such as inconsistent fuel efficiency or unusual engine behavior. It is advisable for vehicle owners to adhere to service intervals that prioritize checking sensors and other electronics as components age. By implementing these preventive steps, the possibility of unexpected DTC triggers can be minimized, ensuring the vehicle operates efficiently and remains reliable. Thus, timely repairs and regular servicing are recommended. In conclusion, Understanding the implications of DTC P2074 is critical for maintaining optimal engine performance in the Honda Civic 2022 and beyond. Following the prescribed troubleshooting steps is essential to accurately identify and resolve issues with the map sensor, wiring, or PCM. Ensuring the proper function of these components not only enhances engine performance, but also improves fuel efficiency and reduces emissions. Regular maintenance practices can greatly aid in minimizing the chances of recurrence. Being proactive about vehicle diagnostics can save significant time and costs in the long run, while enhancing the overall driving experience. Therefore, taking DTCs seriously and responding with thorough troubleshooting and maintenance is a fundamental aspect of automotive care. Please like and subscribe to the channel. See you next time!